As you can tell, my name is Justin Lee. I'm a software engineer at Squarespace in New York City. And this is actually my first time to Sweden. I've been next door to Oslo a couple times, and I have yet to make it over here. So I'm actually very, very excited to be in Sweden. And I'm loving the snow, actually, because it was just kind of cold and nasty, but now it's pretty outside. So anyways, briefly, we'll go over who I am. I've been doing Java for a long, long time. I started as a senior in college. My professor didn't know Java then either, so we were well suited. I used to work for Oracle on the Glassfish and Grizzly teams, where I implemented WebSockets. At the time when I started, there were no EE containers that had WebSockets, and I thought this would be a nice way to carve out a little niche and kind of be ahead of the curve. Now most of them have some form of it, which is exciting. And partly because we have the expert group going on for JSR 356, which is attempting to standardize the Java API for WebSockets. And we're working on both client and server APIs. So hopefully we'll have a solution on both ends that is workable for you soon. That I think we're either in or approaching the public, what's it called, public draft, whatever, which is basically saying, hey, we're really close, we need some comments before we carve this in stone. Because as you know, once those APIs get written, they can never ever change because it breaks everything. So I've been doing WebSockets for a while. Like I said, I don't know how many of you know the tortured history of WebSockets, but it started off in the W3C, got handed to the IETF, and then it was mangled into its current form today. So I've actually implemented WebSockets, I think, like 6 times now because the protocol changed drastically when it went to the IETF. So fortunately, I'm no longer working on the protocol, just the API, which is a little bit saner. How many of you are familiar with WebSockets? Yes. When I started talking about WebSockets, everyone was like, I don't know what it is. So I'll gloss over some of these points because most of you know what it is. But for those that don't, let's do a little bit of motivation about why WebSockets. And ultimately, it's because HTML and HTTP started off very simple request response. I want that thing, give it to me, and then we're done, which was fine for most of the web. But recently, last few years, things have gotten very, very interactive. And so the overhead of making multiple requests to the server gets very, very expensive. How many were in the WebSocket and Speedy talk yesterday? Great. He did. I hadn't actually seen live Speedy code working yet, so it was nice to see. But they did a couple of demos showing the cost of doing HTTP requests and how slow everything is. Because every time you make the request, it comes in, there's header information you have to parse every single time. And then there's all the security constraints that have to be evaluated with every request. And it gets very, very slow. So WebSockets is an attempt to bridge that gap. So you can open one request, and it does all the negotiation, all the header negotiation, everything. And then it just leaves the connection open. And then once it's open, you can exchange information back and forth asynchronously, bidirectional. One side can be very, very chatty, and the other side can never send anything. It kind of doesn't really matter. Either side can do whatever it needs to do without having to reopen a new connection. That's the slide I'm looking for. This last point was important. It's firewall friendly. One of the questions that came up, especially early on in WebSockets, is like, why would you do this? Just open a socket. Well, if you've ever worked in a large enterprise and you ask them, hey, can you open a port on the firewall for me? Most of the time it doesn't really go that well because no one wants to do it, and for good reason. But WebSockets is designed to work over HTTP. The incoming handshake looks like an HTTP handshake. It uses the upgrade functionality built into HTTP 1.1. And it upgrades from HTTP to WebSockets. So when it comes in, it looks like a normal web request. No one's the wiser, but once we're in the door, we're like, ha-ha, now we're WebSockets. And most firewalls don't even know the difference. So that's why it works that way. And before WebSockets came along, of course, those were your options. Ajax being probably the most common and most palatable. Comet, if you've ever done Comet development, anyone? Do you know what Comet is? It's not great. You know, every servlet container has its own implementation, and every time you want to like deploy to another one, you have to, does it work here? Does it not? And it gets very complicated. Servlet 3 came along, which does a little bit of asynchronous, but it's still mostly unidirectional. And then, of course, Flash, Silverlight, and Applets. All three kind of bad words these days. It's not a bad thing. So, anyways, it's now with the IETF doing the wire protocol, what the actual bits look like on the wire. That's actually kind of interesting if you're into protocols, but we're not covering it today because it's a little arcane. The W3C is working on the browser, or the browser into the world, the JavaScript client. And then, of course, JSR 356 is working on the Java EE version. I think I've covered most of this. What I have not covered, it does support extensions. Right now, most of those are compression-oriented. But one of the biggest discussions and what delayed the wire protocol for so long was the question of multiplexing. So you can actually have multiple applications using the same WebSocket connection. That is still pending. I think the biggest vendor who wants it is Google. So they'll eventually get their way. But it was one of those things where no one could agree, and they said, let's just do this thing, and we'll come back to multiplexing. So that's in the way. And it also supports sub-protocols. So if you have a specific format for your data back and forth, you can negotiate that with the server, and you can request and say, I want to use this protocol, and the server can say, I don't know what that means. But at least you know up front what the capabilities are. I have seen, as an example for protocols on top of WebSockets, there's a Stomp implementation across WebSockets. There is XMPP, if you're familiar with that. And Kazing actually has a JMS implementation that works across WebSockets, which is kind of interesting. Where can you use it? Right now, if you're using anything modern, I would say yes, you can probably use it. There's a few notable exceptions. IE gets a little wonky. They're a little late to the game in terms of HTML5 and anything remotely modern. But I will say, IE 9 and 10, the teams seem to have really kind of figured out they can't do whatever they want anymore, and they have to play along. And they've actually been rather aggressive about pursuing compliance to the point where you can actually even download virtual machines with different IE versions to make sure that stuff works. So they're very interested in playing along, which is a nice change. Firefox and Safari and Chrome have had it for a long, long time. Android, the native browser still doesn't, last I checked, have it. But of course you can get Firefox and Chrome on your Android. And iOS 6 has it, but that's actually really recent. I did an older version of this talk at Java 1 back in October, and it didn't support it then, and now it does. So that's actively brand new. So, and of course, it doesn't need to be clients. There are browsers. There are lots of clients. There are libraries in Python and Flash, which is almost a browser technology. All sorts of options. And you can roll your own if you really want to. Socket.io is, I think, JavaScript. My friend Jean-Francois, I love saying that name, he has a project called Atmosphere, which, to be honest, I hope the JSR supplants Atmosphere. That's the goal of it. But what Atmosphere does is it is a layer on both ends, really, where you can write your application to either the Java API or the JavaScript API, and it will figure out, oh, you're on Jetty, or now you're deploying on TomCat, and it kind of figures out what it is so that you only have to write your application once, and you can kind of deploy it into whatever container you're going into, and it handles some of those portability issues. And on the client side, it can actually detect if it tries to make a WebSocket connection. It's like, oh, your browser doesn't support it, or the server you're trying to hit doesn't support WebSockets. I'll downgrade to Comet. I think it started off as a Comet compatibility layer, and he's added WebSockets the last couple of years. So hopefully the JSR will make that compatibility issue go away. If it doesn't, we kind of missed it. Server-side options. There are quite a few and varying degrees of familiarity. Autobahn, which I believe is Python-based. Autobahn is actually a nice project. That's the one project that's really done a really exhaustive suite of compatibility tests, which probably won't matter to most of you unless you're trying to do your own implementation of it in one form or another. but they've been pretty active in doing some tests. There's WebSocket, which I don't know who develops that, but that's out there and it's in Java. TomCat has it. Grizzly and Glassfish have it. There's one called Webbit. Jetty has it. Netty, Kazing, of course, and we talked about Atmosphere. On the other hand, we're only going to talk about these because we can spend all day talking about various different things. But what I want to do is I want to go through, I know there's 4 images, but Glassfish and Grizzly are kind of the same thing. So there's 3 options. Those are the ones I'm most familiar with. So we're going to take a look at how things stand now and then see how those kind of have influenced the JSR implementation because there's some good stuff that's in there and there's some kind of some wonky stuff. So we'll take a look at some examples, then we'll take a look at the JSR. The JSR API is pretty close to being done, and then we might talk about Speedy and HTTP 2.0 at the end. It is called Speedy. When I first saw it, I read it as Spidey, because Spidey sounded much cooler to me in my head. And it's the web, you know, so spiders, whatever. So if I call it Spidey, it's just a mental lapse. I am aware it's called Speedy. But I can dream. Okay, we'll start with Grizzly and Glassfish because I wrote it, so I'm most familiar with it. And there's a couple of key pieces that you'll need to know if you're using the Grizzly API directly. If you've done any comment development, which I'm guessing from earlier hands you probably haven't, the API will look pretty similar because I tried to model it on the comment API to keep our users familiar with certain practices or whatever. So there's an engine that you'll have to register your application with, and of course you have a WebSocket application. The WebSocket object is obviously, it would be like a connection. There is a client API, and there's a WebSocket listener. When I added that, I was kind of working off by myself, and no one was really bothering much, so I was kind of experimenting. The WebSocket listener says exactly that. You can attach listeners and have it respond to certain events. In practice, it turned out to be a little less useful than I was kind of imagining it might. But that said, it's there, and you might find it a lot more useful, but it turns out the base, like WebSocket classes and whatnot, were more than sufficient. And if you're on Glassfish, you will need a servlet to kind of bootstrap the whole thing. If you're doing directly on Grizzly, you don't need any of that. When we look at the different APIs, like between TomCat especially and Grizzly, Grizzly is in a kind of a weird place. We couldn't do anything with servlets because the Glassfish implementation of servlets lives in the Glassfish project. Grizzly is a separate project, and Glassfish depends on Grizzly. We're getting into a little bit of Maven details, but we couldn't rely on the servlet API because we'd have to depend on a Glassfish artifact that would turn around and depend on Grizzly, and Maven freaks out. So the Grizzly implementation is a little bit closer to the metal in some ways than we'll see in some of the others, and that has some advantages and disadvantages. So what does an application look like? It's not as bad as it looks. Most of that you don't really need to know. But there is a create socket method which has a default, returns a default WebSocket. If you don't want to do anything special with it, if you want to use listeners, for example, you just use the default, and that's fine. You can register your listeners. I found most of the time when I was doing demos and writing this or that, I would end up subclassing or overriding this and creating my own subclasses of WebSocket. Because you can use that, the canonical chat example that everyone seems to write when they start doing things like this. And that's where you store your user information and whatever it is about the user you want to store. So most of the time, the demos that I've written have ended up with subclasses of some sort. All right, so there's an onClose method that gets called back whenever the socket closes. You'll see a data frame object there, which is the content. The Grizzly API actually exposes quite a bit of the underlying protocol. Whenever you send a WebSocket message, it can be broken up into frames. And I only say that to explain that that's what the data frame is. And we'll see that actually vanishes in some of the later stuff. So on connect, it's called obviously whenever the handshake is done and both sides have agreed, yes, we're going to talk WebSockets. Is application request is a horribly awkward name, but I couldn't find anything better, and now I'm kind of stuck with it. But it basically, it's how you do your mapping. So you define your URI that you want to mount this particular application at. And that one returns, it gets the HTTP request that comes in. HTTP request packet, actually, because it's Grizzly and not servlets. But it's basically the same. You can check your URI, you can check credentials, you can kind of do whatever you want inside that. Most of the time it's a URI match. The handshake method is where if you want to negotiate specific sub-protocols or extensions or whatever, you can, in the handshake method, add those headers if you want. And on error gets called when something bad happens. The WebSocket interface. This is the Grizzly 2.0 implementation. If you're using Glassfish 3, was it 2 that's out, the latest? I lost track. It is the Grizzly 1.9 API, which is a little, it's actually very, very similar, but the 2.0 is a little bit cleaner. So you have sends, you have pings and pongs, which are basically heartbeat methods. Probably don't really need them necessarily. And then the two stream methods. You can stream either text or binary data, and depending on what you're sending, if you're trying to stream video, you can break it up into byte fragments and send it. Not the best API, but it was early when I wrote it. And then all these various different callback methods. There's an onConnect specifically for that WebSocket instance as opposed to the whole application. There is, onMessage gets called whenever a message comes in. And there's two varieties of that. There's a string and a byte array for text or binary data. There's onFragment, so whenever an intermediary, whether it be a firewall or a proxy or whatever, is actually free according to the wire spec. If you send a message, the intermediary is free to say, well, I want to send messages, and it can break it up unbeknownst to the sender. So you may end up getting fragments coming in, and you may not. Close on ping pong. You can add your listeners, you can remove your listeners. Kind of swingish, I guess, in that respect. There's a close method in there that takes certain response codes that the spec defines. So, what does it look like? To create a server is not overly bad. As you can see, the isApplication request just checks to see that the URI starts with /ping, and there's one method called onPing, and it calls latch countdown. Now, in this case, this actually comes from a unit test from the Grizzly code, so it's pretty bare bones. But the unit test also creates the client. You can see the URL ws://. There's also WSS for an SSL base, much like HTTP and HTTPS. So if you need secure connection, you can do it that way. And this one simply defines an onPong, which comes back from the server. And then you start it, you try to connect, and then you call client.sendPing. And sendPing creates there's a special packet called a ping. Normally, you won't necessarily want to manually send a ping, but you never know. And it sends, in this case, the text ping, which ends up getting into onPing, which calls latch countdown, which in the context of the unit test simply lets me make sure that the message arrived within some sort of time frame. And then, yeah, that's that. So it's not terribly complicated, but it does tend to expose certain parts of the protocol definition that you may not necessarily need to worry about. TomCat took a slightly different approach. It's primarily TomCat 7. I've been told that someone backported it to 6. I haven't seen it. I don't know what version of 6 I'm running on my laptop. The idea was they would implement it on 7, and that would be motivation for people to upgrade to 7 off of 6. And then someone went and backported it and scuttled that plan. So hopefully it's there, but I haven't actually looked at it. They have two interfaces, classes, stream inbound and message inbound, which is again for binary and text data, and then WS outbound for writing data. Now, since TomCat is the servlet container, they actually relied directly on servlets, which I could not, and they have a WebSocket servlet that kind of bootstraps the whole thing. So the message inbound looks a bit different. There's on binary data and on text data, and it exposes an input stream. I chose not to go with stream, although I debated it, because streams are blocking, and I thought, well, you know, there's a whole point of WebSockets, it's async, and you just respond to it when things happen. But after having looked at some of the other APIs and dealt with the expert group, I kind of figured out that, you know, if you're streaming video, you're not just going to, like, whenever you get around to it, oh, there's another frame I need to display, another image. When it comes in, you're going to read it, and as soon as stuff comes in, you're going to hand it off. So blocking when you're reading that kind of makes sense in that regard. So it's a little bit nicer in that regard. But they do have on binary message and on text message as well for callbacks. And those are where you would do your primary work for those. And it is roughly equivalent to Grizzly's WebSocket class. It does represent the remote endpoint, which is ironically what the JSR ended up calling it, remote endpoint. WS outbound, TomCat separated out the read part of the world from the write part of the world, but it exposes some very similar messages or methods. There's no ping method, but there's a pong if you want to send back your whatever, and different methods to write binary and text data. Not sure exactly why they went with char, but sometimes you might just want to send a single letter, who knows. So the servlet. You create, there in bold is probably the most important one, to create the WebSocket inbound. You can override it and provide whatever specialized implementation you need to at that point. And then there's do get, select subprotocol, and verify origin. You're more likely to override select subprotocol than anything else. If you override do get, you're kind of missing the whole point of WebSocket servlet, because that's the thing that hands it off anyways. Why they didn't mark it as final, I don't know, but maybe there's a case where you want to. Verify origin is for CORS related stuff to make sure that you're talking to who you're supposed to be talking to. It's not quite CORS, but it has very similar intentions. So, all right. So what does an implementation look like? In this case, as you can see, we really just subclassed the one method, and we're turning a new echo message inbound. Now, those numbers you see there are buffer sizes. And I believe the last time I checked the API, you had to specify that. Those are very, very large buffers for inbound and outbound. So I'm not sure I would do that in a large application, because that means every WebSocket connection that comes in can have up to, what is that, 2 million bytes. Yeah, and that's just a lot of data to have hanging around. So the inbound implementation looks pretty straightforward. You set in the, oh, it's right. It's not inbound, outbound. It's text buffering versus binary buffering. In this case, yeah, he's setting the size with the numbers passed in, defining two different messages, which just whatever comes in, he echoes right back out. Also not terribly complicated. Not my favorite API. It's a little better in mine in some ways. But it's a little, I don't know, it's a little awkward for me. Jetty is also servlet-based. If you go to their webpage on the Eclipse website is where this particular version of Jetty lives. There's this whole, I don't know, it's like you're walking to a nuclear facility. It's like, you shouldn't use this, it's way too low level. But it's a little bit like saying, don't ever write a servlet directly, use JSF or whatever. Sometimes you just have to. So if you can get past all the hand waving about how weird it is, there's some good stuff in there. They have a WebSocket handler with the WebSocket that defines various callbacks. There is no Java client for Jetty, and there also is no client in the TomCat implementation. They are, they're server-side technology, so they haven't bothered with the client. The JSR is specifying one though, so I believe we are going to require implementations to have a client implementation as well as a server side. So in Jetty, now I should preface this. When I went to the WebSocket talk yesterday with the Intalio guys who are doing the Jetty implementation, they pointed out they're actually hard at work implementing the JSR recommendation, So this API may not be as up to date as I thought it was. But certainly in the earlier versions of Jetty, depending on what version you're on, this is what you'll see. The newer ones, I believe, are starting to track the specification. But this is what it looks like. It's also pretty hands-on. There's a lot of stuff coming in. In this case, they're checking the protocol type that comes in and switching off which implementation they want to give you back. A little awkward. They have an interface for their WebSocket. It's actually not so bad. I saw this, and at first I thought it was kind of weird, but it's kind of grown on me. It lets you kind of specialize your implementation, because you don't always want, if you know you're not going to be dealing with binary data, you don't want to have to carry on all these methods and implement, these empty methods that you're never going to do anything with. It's just clutter. So in this case, in Jetty, you can actually implement specific interfaces such that you don't really have to worry about, I only care about text data, or I'm only streaming video, I don't care about text. And it makes it a little bit simpler. You can also do on-frame if you really like to get down to the guts of what the protocol looks like. And we'll see an implementation of that in a minute. I don't know why you would want to do it, to be honest, because there's all sorts of bits and bytes that specify this frame is this, and if it's this kind of a frame, then these bits mean that, and this is the payload, but unless it has this, in which case it's that, and it gets very, very hairy very quickly. But like I said, sometimes you need to do it, so it's there if you want. So here's a very simple implementation. Extends test WebSocket. Again, these are more unit testy things. And as you can see here, they've overridden on-frame, they call the super. And now you get to check fun things like, is it a control frame or is it not? And if it's a control frame, what kind of control frame? And at that point, you're starting to look at some really low-level things, which I got tired of looking at. I was involved in the hi-bi web working group as they were working on that, and I lost track of all the different control frames and bit masks and whatnot. I just don't see why people would want to do that, but it is there. Which brings us to JSR 356. The first point is a little less urgent than it used to be. Like I said, we are in public draft review, so the API is getting pretty close. It's still changing, although it's changing more in nuance than form at this point. So it's all on java.net. I'll have a link at the end. It's all open source. The mailing lists are open. I think even the source code for at least the interfaces for the specification are all there. The reference implementation is a project called Tyrus, which also lives somewhere in the bowels of java.net, and I think that's public. So anyways, the main points here in the JSR, there's an endpoint, which can be on either end. We have sessions. There are configuration classes, and there's a message handler. I believe it's still an interface. So the API limits the registration of message handlers per session, which is basically a connection, to be one message handler per native WebSocket message type, which would be text versus binary. So you can have one message handler for text, one message handler for binary, but you can't register like 80 different handlers for text data, mainly because it kind of doesn't make sense. But that might open up in future versions, but the reasoning was, in this version, we'll keep it simple, see where the pain points are as people try to use it, and then possibly open it up, rather than create this monstrously open thing that ends up being a horrible idea, but then we're stuck with it because you can't narrow scope once it's out there. So an endpoint should look very familiar. There's an on open, on close, and on error, and they do exactly what they are. The JSR exposes a close reason class, which I should have thought of. I think in the Grizzly API, I send you an int, which you have to know that 1006 is a client close, the remote client close the connection, and you have to know that in order for that number to make any sense, which is not entirely fair on my part. There's an endpoint configuration, and there are separate ones for client and server. But, and this is where it gets kind of fun, and the more I see these other APIs, I realize I missed an opportunity in Grizzly to do some fun stuff. But you can register encoders and decoders, and it sounds, it's exactly what it sounds like. So whenever you send in, you have your WebSocket, and you have your foobar class. You can just say, WebSocket, write this foobar object. And you can register a decoder for, or an encoder, I guess in that case, for foobar that takes that object, serializes it to JSON, and then dumps it across as text. Or you could serialize it to bytes if you wanted to. But it's pretty open-ended at that point. You can do whatever it is that you need to do with it, translate it if you needed to. Now the client endpoint at the moment, and this is where some of the most discussions happening right now, is in the configuration and client stuff. You can specify, you know, what are my preferred sub-protocols. If you're doing chat, you can prefer, like, I really want to talk XMPP, or I'd rather talk IRC if you want to do that sort of thing. You can specify extensions. Extensions aren't really well explained in the specification, in part because they're not terribly well defined in the IETF specification either. We're not entirely sure what people want to do with them yet. So we're, in fact, I think the extensions thing might almost be gone out of this particular draft. There might be an annotation you can add an option to. But we're not entirely sure how they're going to work yet, so we're a little hesitant to try and define this is how it should work when we're not sure about it yet either. So we're hoping for you guys to be able to use the API and say, this is what we need to do, and let, you know, the TomCats and the Jettys and the Tyruses of the world define kind of their own little thing and experiment, and then we can kind of standardize what works. So don't get too excited about extensions because they're kind of nebulous at this point. And then before request and after response. So before request happens before you send the handshake, and after response is what happens when the server returns its content. Then you can inspect the headers and see, I sent a list of 4 protocols that I know how to speak, and the server returned 1. So then you can agree, all right, we're going to talk this particular protocol and move on with life. The server endpoint configuration, that's really a mouthful, is it's a little more complicated. There's a get endpoint class, which is basically the implementation on the server end of the world. The protocols you can use, extensions, again, kind of whatever. Check origin, much like the verify origin earlier. Matches URI, which is a lot nicer to say than is application request. Modify handshake is just that, in case you want to add. You can add certain headers to do whatever it is that you need to do. It is, it's basically an HTTP response, so there are certain headers, basic auth, things like that, that you can kind of pack into your header response if you want. And then there's get path, which is just the URI that it's mounted under /chat or /ping from the earlier example. Message handler is starting to look, it actually looks probably more like Jetty's implementation than anything. There are kind of 2 ways to do it. There's the basic, and then there's the async, depending on how you want to kind of fire and forget, or kind of block where you say send and it returns once it's sent, or you can say send and it just returns and you hope for the best that it finally gets delivered. So there's that. It's kind of in flux as well. So as an example, what would it look like to create one? You can create your server endpoint with the default server configuration. You give it the hello endpoint, so you tell it what your implementation of the WebSocket class is going to be. And the next line is my favorite, server container equal blah, 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 blah. It used to be specified when I first wrote these slides way back, and then it got ripped out of the conversation, and now there's a JIRA issue saying we should figure out how to do server configuration in some sort of standardized way. Right now, each container is going to provide its own way. You might just say new server container, or you might have to ask a juice for this, or do an SPI lookup for that, and none of those are good right now, but there is a JIRA open that by the time the spec finishes, there will be a standardized way to ask the container, give me an implementation of yourself. The client side, on the other hand, is specified. So every compliant container, you'll be able to create the client container just like that. It's pretty straightforward. There's not a whole lot. The default configurations have most of the things with nice defaults. But there's some interesting things there that you can change if you need to. All right, so we create an endpoint. In this case, we're going to check the on open. And we're going to add a message handler. In this case, we're going to respond with basic stuff. So when we get a message, we're going to say, hey, we got your message, thanks so much. And then just send it back. The client looks pretty similar. Yeah, there's not too much difference. Most of it is in wrap concerns based on the tiny window. So in this case, we are just printing out when we get the message back. We're just going to print it. So when you have your client, you can get your session from the client container, which represents your connection after it's been handshake and everything, handshook. You can get the remote, which is the other end, and then at that point you can say, I want to send a string. And the server, in this case, will just bounce it back, and you'll say thanks. Custom message receive. In this case, as I mentioned, we're going to add a decoder. In this case, we're mapping person objects to JSON. So whenever we get a string in, the framework will automatically pick up that decoder, pass it through, and return us back whatever object that decoder happens to do. So you don't have to manually shuffle data in and out of whatever serialization schema you're using. There is an on-error method for you to do when things come in, whatever it might happen to be. Most of the time, it's just closing the connection because there's not a whole lot you can do. But it's there. So, and that is a lot of code these days. But fortunately, we have annotations. When I gave this talk at Java 1, there was just kind of a slug saying we should have annotations, and so there wasn't a whole lot to say. But now the annotations are there, and we'll see how your code changes. I'm actually really excited about the annotations because you start with code like this, which we just saw. This is the server. You know, like I said, it's not like a lot of code, but that's the annotated version. And it's like, what, half the code. And it lets you can see, it's like, oh, this is exactly what I need to worry about. You have your WebSocket parameter, and then it'll parse things out. In this case, it's a very kind of REST-y interface, so it's mounted at the point /hello/message. And the WebSocket param will actually take the message out of that particular parameter and pass it into your do listen method. And then anytime you want something to have to be a handler for an incoming message, you just mark it with at WebSocket message, and the container will hand it off and let you do your thing. And that's pretty straightforward. There's a number of more complicated scenarios. The annotations they're a little bit in flux. Like I said earlier, there's a discussion about maybe we should at least put an add extension or an extension parameter on the method so you can specify some basic extension support. I don't know how long it'll be in there, but there's some debate about it. So that's coming up. We talked about custom framing support because the protocol supports a number of different framing things. I don't know. Multiplexing we haven't really dealt with, like I said, because the IETF hasn't really resolved that question. It'll be an extension almost certainly by the time it gets in. So that'll be handled through the JSR extensions as well. Compression, there is one official extension in the specification, but no one likes it. But it ended up in the I think it's RFC 6455. Nobody likes this compression scheme, but someone thought it would be a good idea to put it in the spec anyways. But I do not believe, well, Grizzly doesn't support it for sure, I know, and I don't think any of the others do as well. So, yeah, anyways. So here are some links for you. 6455, I got it right. I couldn't remember. I always have to think about it. If you want the spec itself, there's the JCP link. All the stuff is there. What's probably more pressing, because the JSRs are kind of boring to read, but the java.net link is where all the work is being done. The mailing lists are there. There's an expert group. There's a users. There's an issues list. You can file JIRA issues. You can post to at least the users list. You can read the experts list. I don't know if non-EG members can post to it, but we see a lot of cross-posts with the users list, so it kind of doesn't matter. and the group has been pretty good actually about responding to random comments on the users list, which is why it was open in the first place. The adopted JSR program, I don't know if you guys are familiar with adopted JSR. One of the JSRs they have adopted is the WebSocket JSR, which makes me very happy. But it took me a second to figure out what's going on because we started getting all these emails and what about it. It's like, what's going on? But there's a lot of good feedback coming in, and I encourage you to read it and play with it and take a look and see, because there are a number kind of warts that I don't like. When I was talking to Simona this morning, yesterday from the Jetty group, there's stuff that he didn't like either. But like I said, now is the time to say something, because once it hits the final draft and we publish it, it's never going away. And I'd rather get it, as right as we can. WebSocket.org is kind of where it all started. That's the W3C's site. So if you want to look at the JavaScript version of it, you can kind of see what's going on there. The Grizzly project, of course, is where my implementation lives, for what it's worth, and then TomCat and Jetty, of course. So take a look. Please play with it. I'm actually really, really excited. When I started, like I said, when I started talking about WebSockets, no one knew what it was, and now I think most of you, at least, are familiar with it. But now's the time to play and get some feedback and let your voice be heard. So that's all I have, and I'd love to answer whatever question you guys can come up with. So fire away. Yes.
I was to the Jetty talk yesterday
Mm-hmm.
when they talked about WebSockets, and I'm pretty sure they bragged about having a Java WebSocket client.
Oh, did they? I missed that line. Okay. Well, that's good to know. Actually, when I looked, I didn't see one. They don't normally do client stuff. What he was saying, for those of you who couldn't hear, he was saying that the Intalio guys yesterday were saying that Jetty does have some form of a client, and that actually might be because they are tracking pretty heavily the specification, and that does require one. So maybe that's where that came from. But so that's good to know. I'll fix my slide. Thank you. Yes, sir. What's that? WebStart? Oh, WebSphere. Does WebSphere support it? I don't think so. It's IBM. WebLogic doesn't either, which is a little sad. But Glassfish has it, obviously, either through both my work and now Tyrus. JBoss has a couple of implementations, I think. I think their project Arai has some WebSocket support. I'm trying to think what are the other EE containers. JBoss, obviously TomCat. But I don't think WebSphere does. I could be wrong. I haven't looked in a while. But last I looked, I don't think they'd even talked about it much. Anyone else? No? Okay. Well, I'm happy to answer questions if you want to stop by, and that's all I have. Thank you.